In this video, we're going to talk about symmetric key encryption examples. The first example is RC4 or ARC4, which has key length that is 40 bits or more. The advantages of RC4 or ARC4 are the fact that it's pretty fast and it has a relatively small footprint, meaning doesn't take up a lot of space or having an impact on performance, meaning very small impact on performance. The disadvantages include, first of all, the fact that it's very weak, and it was cracked. I mean, this algorithm was cracked a long time ago, so by now all these hackers know very well they can exploit this algorithm with very little effort. So one place where this algorithm is used is so-called web wireless equivalent privacy, and I know you're very familiar with this because when you set up encryption for your wireless router, you encounter this algorithm all the time, WEP. So therefore web is not a very good encryption method for wireless LANs because the algorithm has been already cracked and it is very weak form of encryption, symmetric key encryption. So you should avoid web or WEP when you're configuring your router for its encryption. The next very well-known symmetric key encryption standard is data encryption standard, or DAS. So DAS use keys that are 56-bit long, and then typically they add 8 additional bits calculated from the previous 56 bits for error checking purposes. Therefore 56 plus 8 gives you 64 bits, but the actual key length is still 56 bits. The strength of this algorithm is also questionable because the algorithm has been also compromised by brute force attacks many times, and this is why they try to make it stronger by developing an enhanced version of this encryption algorithm. So when I say brute force here, what I mean by that is people trying different keys until they find the right correct key and being able to decrypt a message. So there are these different variations of DAS, and one is double DAS and the other is triple DAS. And triple DAS or double DAS simply mean that you encrypt a message twice or 3 times. So when it comes to triple DAS, like I said, it's a variation of DAS that encrypts a plain text, in this case 3 times, but even triple DAS itself has some variations. So depending on whether you use all 3 different keys to do the encryption 3 times, so that's the first variation, as you can see here. So using so I said 56-bit key for each encryption, so if you use all 3 different keys for encrypting a message 3 times with the same algorithm, that gives you 168-bit key. So this is how they make it stronger, as you can see in the diagram. So plain text goes through DAS algorithm 3 times using unique keys each time, and you get this ciphertext. And then another variation is using the first key, for example, twice, and then using another unique key. So in this case, key 1 and then key 2, but you reuse the first key one more time, so that's why you only have 112-bit key in this case, since you only have 2 unique keys. So here are some thoughts about triple DES. The consequences of using triple DES include the fact that it requires more powerful CPU and more memory space compared to other modern algorithms. So it requires more powerful CPUs and more memory space, as you can see here. And it also takes longer to encrypt and decrypt because of that reason. So it turns out that triple DES is not practical for mobile devices such as smartphones, etc., because of this requirement in terms of CPU power and memory space. So this is why they had to come up with a more efficient alternative for triple DES, which is Advanced Encryption Standard, or AES. And AES is both stronger and faster than triple DES, therefore acceptable for mobile devices. And the key lengths of AES include 128 bits, 192 bits, or 256 bits. There are also other symmetric key encryption ciphers out there. IDEA, for example, is one developed by Europe. SEED, or SEED, developed by South Korea. GHOST, developed by Russia, and Camellia, developed by Japan. So every country has its own encryption algorithm developed in terms of symmetric key encryption, because they don't want any other countries to be able to decrypt their secret messages.